Welcome back. Wolfers here. Looking to make games using Unity? Well, you have come to the right place. Let's get started.
Okay, so let's get started by opening the project we created last time. To do this, we have to go into Unity Hub and then go into the project section and select your project. Having a file structure is very important from the start. This will allow us to maintain and grow our projects with the least amount of headaches. Having things organized and knowing where things are, especially when a project gets big, can save you a lot of time. My typical file structure is as follows. So we have an assets folder. Everything in this folder is going to be part of Unity in our project. So the first folder that I like to make is our project name. The second folder that I like to make is, depending on where I am in development, we either have a prototype or production folder. In this folder or these folders, we will have art folders that's going to contain all of our art assets. We have an audio folder with all the music and sound effects and all of that stuff. We have a resources folder that this application is going to need to load at some point. We have prefabs. These are objects that you create, such as like a main menu that have preset, information and stuff like that. Or if you're trying to um, procedurally create something, you would put your prefabs in here. We'll talk about prefabs more in a later video, but anyway, let's continue. So scripts is another folder. Will contain all the functionality of your game, and scenes, which will contain all the levels of the game. There's probably other ones that I'm not mentioning because I can't remember, but that is pretty much the file structure that I follow every time. We are going to be looking into how we can program something today. For our first project, we're going to be creating something simple, Pong. We are going to make a ball bounce around the screen today. So let's go into the scripts folder we created earlier and right click on the project window. We are going to go to the create and then into C# script. This will create a new C# script for your project. Make sure to name it ball.cs. You don't have to put .cs. It does that automatically.
If you enjoy my videos, hit that like button and subscribe if you haven't already. Click on the bell icon to get notified when new videos get uploaded.
Alright, so we're going to double click on it to open it. Notice that this file inherits from a class named MonoBehavior. This class is necessary to have objects use Unity's API like start, awake, update, fixed update, and many other ones. This class also allows these scripts to be attached to any game object and to show its properties in the inspector. We will be making use of this class a lot, so keep in mind that not all objects need this class to properly function. Alright, with ball script open, let's get started. We are going to need a few member variables in this class to keep track of the ball's position, direction of travel, and speed. These will all be private. Let's set the transform to null since we don't have any reference to this yet. The starting value for the ball speed is going to be 10, and for the direction we can say it's vector 3.0. This will make the vectors 3, x, y, and z components or values all 0. Alternatively, you can say new vector 3 0, 0, 0, but we don't always have to do this. In the start function, we are going to make sure these variables have proper values. The ball transform will be referencing the game object's transform so that we don't have to constantly fetch it from the game object itself, since this can be costly. The ball speed, we need to make sure it is not 0. Otherwise, the ball will not go anywhere. And we also need to make sure that the ball direction is going somewhere. It cannot be all zeros. For now, we're just going to give some random numbers here from -1 to 1 and making sure that if it is 0, we just change it to something else. We need to make the ball move in the same direction as the ball direction is pointing towards. To do this, it's pretty simple. All we need to do is to get the current position and add to it the direction scaled by the ball speed times delta time. Delta time is used to make sure that the movement on all devices and computers are similar. We don't want our games to run either super slow on one machine and then super crazy fast on another machine. To make sure they are all consistent and going at the same rate, we need to make sure that we scale any movement by the application's delta time. Okay, so now that we have this, save the file. Let's head over to Unity and make a ball game object like we did in our last video. If you forgot, these are the steps. Let's right click on the hierarchy window, select 2D object, and choose sprite. This will make a new game object with the sprite renderer component. With this object selected, go to the inspector window and find the sprite renderer component. Let's change the sprite property and add a new image to it. I'm going to use the knob like we did in the last video. Make sure that the ball is centered on the origin position, which is X, Y, and Z, all 0. We are also going to leave the scale as is, 1, 1, 1. This object now needs a rigid body to D. So let's click on the Add Component button and type rigid body to D and press enter. Let's make sure that the body type of this rigid body is set to kinematic. This is so that Unity allows us to use our own code for the physics of this game instead of using the built-in functionality. One more thing I forgot to mention is that this object also needs a circle collider 2D or circle collider. Lastly, we need to drag and drop into the inspector our ball script that we made. This will add our code and functionality to this object. Awesome. Let's test it out and hit that play button. You should see it move now on its own, and every time you stop and play it again, the direction should change and it should never be 0. Okay, well, that's great and all, but we need to make sure that the ball stays. Let's make it bounce around the edges of the screen. To make the borders, we are going to make several new empty game objects. We are going to call the first one wall border underscore top. In the inspector, we are going to add a box collider to D. Once added, make sure to check the box that says trigger. This box will be the top of the screen, so we can change the size vector within the box collider to D to the following: 21.20 for the X value and 1.0 for the Y value. We are going to position it above the edges of the camera on top.
Let me know in the comments down below what you learned today and what you thought about this video.
With this new game object selected, right click on it and on the hierarchy window and select duplicate. Rename it to wall border underscore bottom. Move this one to the bottom of the screen. We don't need to worry about changing anything else since it's the same as the top. We are going to create the other two sides now in the same way we created the bottom. Let's rename these new copies to wall border underscore left and wall border underscore right. Select both of them and then go into the inspector. We will now need to change the size parameter for the box collider component to the following. X is 1 and Y is 10. Then we're going to position the left to the left and then the right to the right edges of the screen. Awesome. If we try to play again, notice the collision is not working at all. This is because we need to create ourselves that functionality. Don't worry, it's not that hard. In the project view, go to the screens folder and right click to create and select C# script. We're gonna rename this one to ball collision, and this script will be responsible for deflecting the ball into whatever direction it needs to go based on where it hit and what object it hit. This script will contain one member variable to determine where the ball should bounce to next. It will be private vector3 normal direction equals vector3.1. Make sure that in front of it we add the following serialized field. This property will let Unity know that we want to access this variable in the inspector. By default, private variables are not shown on the inspector. Now we need to add the following function, onTriggerEnterToD. This is another Unity built-in function which lets us use our own code when colliding with other objects. The first thing we need to check is to make sure to only allow the ball to be collidable with this object. We will be ignoring anything else. Inside of this if statement, we are going to calculate the new direction the ball should move towards to next, and to tell the ball that it needs to do that. For this, we will need to know vector math, which we will use the reflection formula to make sure the ball bounces. This function uses the dot product. The dot product will give us an angle between these two vectors. The formula reflection is as follows. R equals D for direction minus 2 times the dot product of direction and the normal times the normal. First, we need to get the ball script from the collision object coming in through this function. To do this, we just get the collision. The collision contains a reference to the game object, and the game object contains functions to get components from itself, in which case we're gonna get the ball component or script. We will store it in a variable. We're gonna name it ball. Next, we need to get the current direction to the ball in which it's traveling and store it in a separate variable named direction. To get the current direction, we just call the ball dot ball direction. Awesome. Now we have all we need to make the ball bounce. And the only thing that we need to do now is to let the ball know that it should move, which we just need to say ball dot ball direction equals new direction. And done. Save the file and let's head over to Unity. Add the ball collision script to each of the walls as a new component. All we need to do now is to let each wall know what their normal direction is. This is the direction in which the walls are facing, so let us set them up. The top is going to be 0, -1, 0 because it's facing down. The bottom is going to be facing up, so the normal is 0, 1, 0. The left is going to be facing to the right, so it's 1, 0, 0. And the right is facing to the left, so it is -1, 0, 0. If we have done everything correctly, we should now see the ball bouncing around and changing its direction as it hits the walls. I think this is a good stopping point. I encourage you to play around with what we have made today. Try to understand completely what is happening inside of the scripts. Change stuff around and just have some fun.
If you like this video, smash that like button. This is to let YouTube know that this video was worth watching, so other people can find it. Don't forget to subscribe and click on the bell icon to get notifications when new videos get uploaded. Stay tuned for our next video. Don't forget to connect with us on social media. If you want a way to support what I do, head over to my Patreon page. The links are in the description down below. Thank you for watching and see you next time.